Hey guys, welcome to my channel, and today we'll be solving question number 106 of LeetCode. That is construct binary tree from Inorder and PostOrder Traversal. So I'm hoping that everyone knows what is a binary tree. Basically, it's a data structure where there is a parent and then there are two child, one towards the left and one towards the right. So let's take this example and understand how we solve this problem. Let's just say, okay, let's just copy down the question here. It is 3, 9, 20, and 15, 7. Okay, so 15 and 7. Okay, my handwriting is a bit bad. I hope you can adjust to that. Okay, let's just write the in order traversal of this. That is 9, 3, 15, 20, 7. And post order traversal, let's just see what it is. Okay, it's 9, 3, 15, 27, 9, 15, 7, 23. 9, 15, 7, 20, and 3. Now, all of us, I'm guessing most of you know that in order traversal is left, root, and right. Post order is left, right, and root. Okay. So one thing we are sure about post order traversal is the last element is always the root element. And in case of pre-order, it is the first element, that is the uh, root. So now let's use this node. So we want to traverse from the last. This is the, I'll just remove this. Yep, go there. Okay, now let's take brush, I guess. Okay, so now this is post order and this is in order. Okay, so we want to traverse from the last element of post order because the last element is the root node. Okay, so we'll just keep this is the last element is 3. So now just to make, I don't have a lot of space, so we'll just take this out. Right, brush. Okay, so last element is of post order is 3. So now we just write 3 here. Okay, so now we want to check where is 3 in order. So we'll just keep a pointer here pointing to 3, and since 3 is already visited, we'll just strike it off like that. Now in the next iteration, so this is gone, now it comes to 20. Okay, now we want to see towards which side is 20. Is it towards the left or towards the right? So now we see that 20 is towards the right, and when 20 is towards the right, we want to check what is the element that is nearest to it, that is visited already. So now 20, we're going to the right, and we know that 3 is already visited. So we know the nearest element of 20 is 3, and 20 is towards the right side of 3. Okay, so we'll just, from 3, we'll just put right to 20. Okay, so now this pointer moves to 20, and 20 is striked out because 20 is visited. Now in post order, we come to 7, the next element, 7. Now again, we have to check from 20, is it towards the left or towards the right? We see it is towards the right, and the nearest visited element is 20. Okay, so from 20, we'll just put a link towards the right, and the value will be 7. And the pointer will go to 7, and 7 will be striked out because we have already visited that. Now in post order, we come to 15. Okay, now 15, we want to check from 7 towards which side is 15. We know from 7 it is towards the left of 15 is towards the left of 7, and we know the nearest element that is visited is 20 because this is visited and it is towards the left. So 20 is the nearest element of 15. Okay, so from 20 we want to create a left link connecting 15. Okay, now the pointer comes to 15, and 15 is striked out because we visited that. Now final element is 9. Okay, so 9, Now again, from 15 we have to check if it belongs to the left or towards the right. Now we see that 9 is to the left of 15 and the nearest element that is visited is 3. So what we need to do is connect 9 towards the left of 3. So 9 is connected. Now we just move the pointer to 9 and 9 is tied up. Now here we can see that all the elements are visited in both the in order and post order traversal. And we can also verify that this is the tree that we required from the question. That is 3, 9, 20, 15, 7. 3, 9, 20, 15, 7. So this is the logic behind solving in order to constructing trees from in order and post order traversal. Now we look at the code. We basically have to return pointed to tree node, basically pointing to the head, and we are given in order and post order in vector int. So to start off, we have an ordered map that maps each element val to node star. This makes it easier for us to basically link elements with the key value. And we have a head pointing to the root element. And current pose is -1 because when we start, there is no previous element or anything to link to. So current pose is -1. So as a first step, we have to fill up the unordered map. So we loop through all the elements in order traversal, and we just make node for each of them and insert them into the map. Now we just assign sign to a variable, and vector int of visited is size comma 0 because, like I told you, every time we visit an element in order, we need to strike it out. So that is represented using visited array. So now before we go any further, I want to show you something that I used in my code. That is, I used a struct element, user defined struct. Basically, I made this because I want to get all the element details at once. That is the direction, the nearest element, the element that is visited, the position of that element visited. So all that is returned by just one structure. So that should basically tell you why we have a structure here. And now we just assign current to post out of I because just to make it simpler, I don't want to say post out of I every time. So just in current equals post out of I. And before that, we are looping from the last element to the first element. So that's why int I equals size -1, size -1, I greater than equal to 0, I minus minus. Okay. So now in the first if condition, we are checking if current position is -1. Why do we do that? Because we want to check if we have visited element previous to that. No, we haven't visited any in the first iteration. So this condition is true. So first of all, it sets the head to UMP of current because that is the head element of or root element. And after that, we need to set visited of root to 1, and we also need to get the current position of that visited element. So we call a function called set starting node that we have defined here. So what this function does is basically it loops through the in-order traversal, the vector of in-order traversal, and checks if the in order of a particular index equals to the num or current element. If it is true, then we set that element to 1. I mean, set the visited of that element to 1 and return the position of that particular element. So in by the return type, by the return, we can set current position to that index. And next step, we just continue because we don't want to go any further. We just set the head node. Okay. So now current position has changed from -1. And in the next iteration, and in any further iterations, it is never going to visit this loop, this condition again. So now let's focus on this. So now we're getting a pointer of element through the function called find element, which takes it in order, visited, current, and current position. So let's look at the function. So this function does basically does nothing but finds the element and tells in which direction is the element in, and the nearest element that nearest element to the particular search element. Okay. So here we just said nearest viz equals current number of nums of pose. Why do we assign that? Because we know that if we are going to search for an element that is adjacent or near to a number, obviously that number is already visited, right? So we just set nearest visit to that particular number. Now we just get size of the in order traversal. Here it should have been in order for better understanding, but I've taken as nums, so I guess we can deal with it for now. So now in the first for loop, we are checking for left side. So we start from post -1 and I till I equal to 0. So if we find that nums of I equal to the search number, that is int of num, if we find that, then we know that number is there on the left side. So we simply set visited of I equal to 1 because that particular number is visited now, and we return an element with the position of I, the nums of I, that is the visited number, and the nearest visited element, and the direction, that is to the left side. Okay, and the next condition is if visited of I equal to 1. Why do we check this? Because we want to know if there is a visited element towards the left as we are moving further towards the left. So the nearest element will be the last element that is visited, right? So every time we encounter a visited element of equal to 1, we simply set nearest visited equal to the number at that position. Okay, so the first loop simply returns if if the element is present on the left side. Now we go to the second loop, and here we just reset the nearest visited to nums of post, and it basically follows the same logic, but it is moving towards the right. Okay, so this particular loop will return the element if it is present on the right side with the nearest visited element. Okay, and the loop, this function will never come to this return statement because we know that the number has to be present on either side, either to the left or to the right. If it ever comes to this return statement, it means there's something terribly wrong. Now, yeah, so now we return control to the element ele, and now we just simply set current post to element of post because now that is a currently visited element. So we just update current post, and now we check if we check for the direction, that is if it is towards the left, then we go into this if condition. Otherwise, we just simply go to the next condition, the next else part. So now, like I said in the explanation, that every time we are connecting nodes, we need to connect from the nearest element, right? So we just take UMP of element of nearest. If it is towards the left, of left equal to the current element, and if it is to the right, we simply point the right of right to the current element, and this goes on. This loop goes on till the till I equal to 0. Okay, and finally, we simply return the head that is pointing to the tree. Okay, now let's run this code and check if you're getting the output. And sure enough, we're getting the output. Let's just submit this. And like you can see, I've already submitted this quite a lot of times. And this time I actually got the best results. That is 25 milliseconds, faster than 62.17% of the C++ solution. That is pretty good, I guess. It's simple and very intuitive solution. And I hope to see you guys in the next video. Please subscribe to my channel and see ya.